statisticians. I hope your studying is going well. This is part 1 of the review. Part 2 of the review is going to be on a separate paper. And at the end of the review, just to make sure that you watched it all the way through, there's going to be a secret word or phrase. I want you to write the secret word or phrase on your test. Don't say anything about it to anyone else to prove that you watched the whole video. Alright, part 1. We're going to start by sketching our bell curve. It doesn't matter if it's perfect or not, as long as it's approximately bell-shaped. Remember, your mean is going to be exactly in the middle. One standard deviation away is going to be 2.9. 2 standard deviations to the right is going to be 3.2. And then 3 standard deviations to the right is going to be 3.5. We're going to do the same thing with our standard deviations to the left. 1 standard deviation to the left is 2.3. The next standard deviation to the left is 2.0. And then a third standard deviation to the left is 1.7. I'm going to do the same thing for B, C, and D. You'll notice for part B, my mean, 10, goes exactly in the middle. And then I added or subtracted 1, 2, and 3 standard deviations. For part C, my mean, 20, was right in the middle, and then I added or subtracted 5, my standard deviation. For part D, my mean, 31, was right in the middle, and then I added or subtracted 4, my standard deviation. Part B says, on your last 4 graphs, shade the portion of data that are A, less than 3.2, B, greater than 8, C, greater than 30, and D, less than 35. These guys you could get straight from your notes. 68% of the data lie within 1 standard deviation to the left and 1 standard deviation to the right of the mean. 95% of the data lie between 2 standard deviations to the left and 2 standard deviations to the right of the mean. And then lastly, 99.7% of the data, almost all of it, lie between -3 standard deviations and +3 standard deviations. For number 3, I just wanted you to remember what a normal curve looked like. The mean is exactly in the middle. The mean minus 1 sigma, the mean minus 2 sigmas, and then the mean minus 3 sigmas. On the right, we have the mean plus 1 sigma, the mean plus 2 sigmas, and then the mean plus 3 sigmas. This percent would be 68. This percent would be 95. And then this percent between mu minus 3 sigma and mu plus 3 sigma would be 99.7% of the data. Practically all of it. Number 4, some real-world examples that are normally distributed. Height, weight, arrival times, and quiz scores, although hopefully on tomorrow's test we have more A's than we do E's. What does it mean to be normally distributed? Most of the data is clustered around the mean. Which is also the median. Number 6. The weights of McDonald's cheeseburger patties have a mean of 5.1 ounces and a standard deviation of 0.2 ounces. Sketch the normal curve, labeling the 7 important points of the horizontal axis. So I'm going to do that first. For my sketch, I drew a bell curve with the mean, 5.1, right in the middle, and then I labeled my other important points. If I want a range that 68% of the data fall within, according to the empirical rule, 68% of the data fall between -1 sigma and -2 sigma. So my range would be 4.9 to 5.3. 95% of the data fall within 2 standard deviations, so my range would be 4.7 to 5.5. A range that 99.7% of the data fall within would be 3 standard deviations to the left and to the right, 4.5 to 5.7. For part D, I would notice that 47.5 is half of 95%. So what I would do is take half of the range from part B. Instead of going from 4.7 to 5.5, 47.5% of the data would lie between 4.7 to 5.1. The last problem on this section, give the percent that lie in each shaded region. For part A, I notice that this is 1 sigma to the left and 1 sigma to the right. Using the empirical rule, 68% of it is the area. Part B, I also use the empirical rule. 2 sigmas to the left and 2 sigmas to the right means 95% of the data. To find part C, I would notice that this diagram is actually half of that one. So I'll take half of 68, which is 34%. Part D, the percent is 50 because it's exactly half of the curve. Part E, I notice that this graph is half of part B, so I'll take half of 95, which is 47.5. The secret word is lentil. Remember, just quietly write this on your paper. Do not say anything to anyone else. And then for part F, you have to do a little bit of problem solving. Remember that 68% of the data lie between 1 standard deviation to the left and 1 standard deviation to the right. Since 68% fall within this range, then 32% fall in this tail and this tail. If I only want this tail, I would divide 32 divided by 2, which would give me 16% in only the lower tail. Make sure you watch part 2. It's a separate video.